Okay, in the last video, we did some integrals that had sines and cosine terms in them, and one of them was raised to an odd power. And we found that there were ways that we could handle those. Here we have integrals now of sines and cosines, where at least one of them is raised to an even number power. And the way we handle those, we approach it like this. We start from here, realizing that the cosine squared plus the sine squared, of course, that's just 1. And if we take the difference between these two, instead of adding them, we end up with the cosine of 2 theta. And then, if we substitute for one of these, say this one, and we call it 1 minus the sine squared of theta, then on this side of the equation, we're going to have 1 minus 2 times the sine squared of theta equals this. Or if we solve for the sine squared of theta, we get this expression. So if we're trying to do an integral, trying to integrate something, and this term pops up, we use this formula, because this we can integrate. And same thing for the cosine squared. It's the same deal, except here we have 1 plus the cosine of 2 theta, instead of 1 minus the cosine of 2 theta. So these two expressions are definitely well worth remembering, and if you think you have difficulty remembering them, it's very easy to derive them. But let's see how we can use this now to solve some problems. We've got 4 of them here. Integral squared of the integral of cosine squared of 3x, plus the integral of the sine of x to the 4th power, plus the integral of the sine squared times the cosine squared, and then we have 1 over sine to the 4th. And it turns out you can't do this one without knowing how to do this one. So we're going to take these in order, and we'll start here. Here we have cosine squared of 3x dx. And if we had, instead of 3x, if we had the cosine squared of u, then we'd be all set to apply our formula. So we can make it look like that easily enough. Let u be equal to 3x. So 1/3 of du will equal dx. So this will become equal to the integral cosine squared of 3 times x, and dx, that's 1/3 du, except we don't want 3x, we want u, like this. Okay, now we're all set to apply the formula, so this would be equal to 1/3, and here we have a 1/2, so take that out to our integral sign. And now we're going to have the cosine of 2 times u plus 1 du. So this would be equal to 1/6. The integral of 2 times u, the integral of the cosine is plus the sine, so that would be plus the sine of 2 times u divided by 2. And hopefully you recognize right off the bat why we do it like that, but just to make sure, we have this integral here. Well, if we call this, say, p, then this would be 1/2 dp. So we'd be taking the integral of p 1/2 dp, that's the sine of 2u times 1/2. So that's why it works out like that. And then here we have plus u when we integrate, times 1/6. And u, we have to go back now to our original substitution. U is 3 times x. So we get then the integral cosine squared of 3x dx equals 1/12 times the sine of 2 times u, that would be 2 times 3 is 6, that would be the sine of 6x, plus u is 3x. So 3 divided by 6 is 2. So that would be the integral here. Integral squared of 3x is 1/12 times the sine of 6x plus 1/2x plus a constant. So you see, there's no way that you could, anybody for that matter, could look at this integral and simply just somehow divine it had to be equal to this expression here. The only way you can possibly handle it is to use our identity. And of course the answer falls right out for us. So let's see if we can handle some of the other problems that might be a little bit more complicated. The next one that we have is sine to the 4th of x. So let's see, we know that the sine squared of x, that's equal to 1/2 times 1 minus the cosine of 2x. We have sine to the 4th of x. So that will equal this side squared. So we're going to have 1/4 times 1 minus the cosine of 2x. And we have that whole quantity squared. And let's see, if we multiply this out, that would be 1 minus 2 times the cosine of 2x plus the cosine squared of 2x. And this is multiplied by 1/4. So it looks like this integral here is going to be this integral right here. So we have 1/4, the integral of 1 minus 2 times the cosine of 2x plus the cosine squared of 2x dx. And let's see, let's take this integral first. So we have 1/4 times the integral of the cosine squared of 2x dx. And now we do what we did before, we make our substitution. That's pretty straightforward. Let u equal 2 times x, so 1/2 of du will equal dx. So here then, this will be equal to 1/4 times the integral of the cosine squared of u, and dx, that's 1/2 du. So we have times 1/2 du. Now we're all set to go ahead, apply our formula. This is 1/8. So let's write it down here. Give us some more room. This will equal 1/8. And I'm going to apply this formula here, so the integral, take the 1/2 to the outside. And we have the integral for the cosine of squared of u. That is the cosine of 2 times u plus 1 du. And that will equal 1/16. And the integral of 2u, the integral of the cosine is always plus the sine. So that's the sine of 2 times u divided by 2. And the reason why we divide by 2, we have this integral here. If we say call this p, we have the cosine of p, that will be 1/2 dp. So we're taking the cosine of 1/2, the cosine of p, which would be the sine of p, which is 2u times 1/2, and that's what we have there. So that's okay. Then we have plus 1/16 the integral of this du, and that's u. And let's see, what is u? That was our substitution right there. So this is equal to 1 over 32 times the sine of 2 times u, so that will be 4 times x, plus u, that's 2x. 2 divided by 16 plus 1/8 x. Okay, that was for this integral. That gave us this. Now we have this integral. So let's deal with that one next. 2 forces 1/2, so that will be minus 1/2 the integral of cosine of 2x dx. And we know what that's going to be, because we have minus 1/2, and that's going to be the sine of 2x divided by 2. And then looks like that will be it for that. So this equals minus 1/4 times the sine of 2x. And that was from this integral. And then finally we have 1/4 the integral of dx. That will be x over 4. So let's see, we have to add this, this, and this. So here we have x over 4 and then we are going to have minus this, x over 4, that just came from this integral right here, x over 4, and then for this integral, that was this expression. So we have x over 4 minus 1/4 times the sine of 2x. That was from this integral right here. And then from this integral, we have this, plus 1 over 32 sine of 4x plus 1/8x plus an arbitrary constant. And this is 2/8 plus 1/8. That would be 3/8x. So that right there, that is the integral sine to the 4th of x dx. We have 3/8x minus 1/4 times the sine of 2x plus 1 over 32 times the sine of 4x plus a constant. And as you can see, without these formulas here, there's absolutely no way that we could have hoped to be able to solve this problem. I think we're going to run out of time here. So come back and join us in the next video, and we'll tackle these two problems using these formulas along the way.